Thank you, Rami, for the very kind words, and welcome you all. I'm really thrilled to be the next to really welcome you to NXTWORK 2017. Hopefully, you're having a good morning so far. As you know, at Juniper, we're really taking an aim at complexity. And Rami has laid out some of the very key principles that we're going after. So in the next 30 minutes or so, I really want to build upon that principle and explain to you what we're actually doing to make network simple. And specifically in this talk, I'm actually going to go after one of the most complex problems of today, that is multi-cloud, which is important, which is necessary. It's probably in all of your roadmap, but it's incredibly complex. So my goal here is to really go after this problem in a principled way and explain to you how we're going to solve it. You know, as Rami said, I actually spent a decade at Google before coming to Juniper in not only developing and building some of the very important technologies of the last decade, but actually deploying them and running them and owning the infrastructure that actually every single Google applications and Google Cloud relied on day in and day out. Talk about mission-critical applications and mission-critical infrastructure. And in doing so, I actually have learned some very key principles over the last 10 years, right? And I have to say that I actually bring some fairly unique perspective to network in general, but to multi-cloud specifically. When you develop a technology, but when you also are ultimately responsible for the technology being up and running, as most of you are, you actually start thinking of the problem in a very different way. It's not about feature, it's not about function, it's not about the coolest thing that you can develop. Well, I'm an engineer, like that, all of that excites me. It really excites me, but end of the day, it is about whether my infrastructure is up and running and doing what it's supposed to do, right? So if I have to really summarize, what are those things that I've learned over my 10 years of really building a really large hyperscale infrastructure? The first one, future belongs to the fast. What do I mean by that? Every one of you, of course myself included, we are witnessing old technologies or products or business models are being disrupted every single day. How many new fundamental technology changes we have seen in networking over the last 5 years? I mean, let's start with software-defined networking. I actually worked on that even before it was called software-defined networking. Network function virtualization, white box, DevOps, multi-cloud, it goes on and on and on. And I'm willing to bet, I've been in this industry for several decades now. I'm willing to bet that you have seen more changes in the last 5 years than you have in the 10 years before or more in the 10 years before that. It's exponential. And if you don't stay with this change, or if you don't stay ahead of the curve of this constant change, you're going to be left behind, or your industry, or your product, or your business model is going to be disrupted by somebody. So what stops us from being fast? We all want to be fast. We all want to be the market leader. We all want to see the future before others do. What stops us from being fast? This is another thing that I've given a lot of thought, and what it really comes down to is complexity. Why is complexity an anchor? Complexity is an anchor because ultimately, being fast is not enough. You got to be fast, but you also have to be reliable. You also have to be economical. You also have to run your business. And if you have to take all of this complexity with you when you're trying to move fast, you always run into the problem of, OK, I've left reliability behind, or I've left economics behind, or I have left all my users behind. That's the worst case scenario, by the way, right? And so when you do that, being fast itself is not very good, right? So complexity holds you back. You want to be fast, but you can't. Now, if that's the case, then how do we go about solving it, right? And one of the questions that I always get asked is that, look, you actually have run one of the most complex infrastructure in the world. Why is this hard? They have solved it. Well, let me share some secret with you. Hyperscalers, Google included, but everybody else in this space who are hyperscalers, they actually had some advantages. They did not have a whole lot of legacy. They, in most cases, started with greenfield. They could design their infrastructure so it's more or less homogeneous. And even though they run lots of applications on them, when you peel them out, you'll actually find that underneath the application stack, there is an enormous amount of homogeneity. And of course, they had an army of software engineers. So when you combine all of that, They actually build an infrastructure that is amazingly scaled out, that is probably most automated on the planet that you can think of, but it is not complex in the same way that an enterprise infrastructure is. Because they didn't have to deal with the legacies that have been around probably for 10 plus years, not because anybody loves legacy, but because you must support it, because your applications rely on them. They did not have to deal with this, hundreds of thousands of applications that you deal with every single day, again, not because you love them, but because your business rely on them. You can't throw them out tomorrow and say, look, from now on, everything is on cloud and life is good. You wish that was the case, but that's not reality, right? That is not what you deal with every single day. You have to deal with users that are all over the world with connectivity that are very, very diverse. They're not all connecting through this beautiful IP MPLS network. Some are connecting on SD-WAN, some are connecting on VPLS. You have all this technology that you manage because you must, not because you love them. Enterprise is way more complex as an environment than any of the hyperscalers are. So all these are fact of life, right? There is no getting around the fact that we want to be simple, but complexity holds us back, and we have to deal with this infrastructure that is complex by nature, because that's the problem that we're solving. How do you go about solving it? Two words that you heard Rami say, 2 words that I'm here at Juniper for, is engineering and simplicity. Simplicity cannot be an afterthought. It is way too often that people say, look, I have built all this complex thing, and now I'm going to build this magical software on top, and life will be simple. I have never seen it work. Simplicity is not an afterthought. Simplicity is something that you engineer from day one. And you engineer in every layer of your infrastructure with the goal of making it simple when you're running it. Simplicity cannot be an afterthought. It has to be designed. And it's not easy. It's actually very hard to design something that is simple. When you go and use Google Map, it's simple to you, but if you look at the layers of complexity that are underneath, that are just hidden away or abstracted away from you. It is not simple. It's the abstraction that has been built in layers. And so, you have heard Rami say simplicity is not easy. Clearly, I pointed out how it's really not, something where you can wish away complexity. It is not easy. Simplicity is also not rigid, where you never have to trade your flexibility for simplicity. That's the wrong choice. You shouldn't have to choose something that boxes you in one solution or one vendor or one application because that's the price that you pay for simplicity. That cannot be the case. That's not simple. It cannot be limited. It cannot be that, I have this little thing that is very simple to manage, but I have this many other things that are very, very complex. Look, I have this amazing console in public cloud that makes all of these things so simple with management and visibility and all of that, but I'm left with my OpenStack deployment in my data center. That's incredibly complex. Well, you really haven't solved any problem at that point, right? But let me focus on the most important part of what simplicity is not. It is not abstract. It is not just a concept. It is not just an idea that somehow on top of all this complexity, I'm just going to build an abstraction and life will be simple. I'm certainly have been in conferences like this one. You have heard speakers like me talk about simplicity. And you have seen nice PowerPoint presentations, kind of like this one, with nice cloud icons, kind of like this one, with nice lines drawn. And they say, look, your life is simple now. It's all in cloud. And you go back to work next day, and you're dealing with the 25 dashboards and all these protocols and all these things that are broken all over your infrastructure. Life is exactly as it was the day before. It's not a PowerPoint slide. I'm an engineer, and I have spent my life solving hard problems. That's why I'm here. Simplicity is the hardest problem to solve, and we're actually solving it. It's not a PowerPoint slide. So we're actually going to go and show you how we're solving it principally. How it's not an abstract idea, how we're taking aim at the layers of complexity, and we're trying to solve them. So the whole promise of cloud has always been simplicity, right? And if you really look at, break it down into what cloud really offers. I mean, there are various views as to what cloud really is to people, but to me, it has always been 4 things. Fungibility, you get the infrastructure when you need it, and as much as you need it, and then you pay only for what you need. It's fungible. It's reliable. It's there when you need it, whether it's a file system or email or map when you're driving. It's there when you need it. Secure, when you're connecting to this infrastructure, you actually don't have to trade off your security because it's actually all over the place. It's secure. And ubiquity, you get it where you need it, whether it's here or whether you're flying through an airport or whether you're in a different country. You get access to the same infrastructure with the same reliability, same security, and same fungibility. That's actually the beauty of cloud. Now, the interesting part is, these 4 qualities are the qualities of any great infrastructure that you see around you. As Rami said, best infrastructure are invisible. They're invisible because they follow these 4 principles. Think of running water or think of electricity. You can apply all these attributes to them. Your running water is fungible. You pay for as much as you need. They're reliable. They're there till you have drought like we have in California, and then you realize they're not there. They're there when you need them. They're secure. You can safely drink your tap water because they're secure, and they're ubiquitous. You get water wherever you go. That's what a good infrastructure should be. That's what a promise of cloud is. Now, here's the good news and here's the bad news. If you go with one public cloud, you can hope to get kind of like that infrastructure. But that's not real life. The real life is you actually have infrastructure that you have built over decades. You have infrastructure on which your mission-critical application runs every single day. You have your on-premise data center. You're probably migrating from bare metals to VM-based to OpenStack and OpenShift and Kubernetes and the modern ways of building cloud-native infrastructure, but they're on-prem. You also have your branch offices that are all over the world, and your users and your employees rely on you for connectivity to these branch offices. You probably have built a set of colo and POPs where you host some of this equipment, and you connect the world. And of course, you're trying to get connectivity to public cloud, but not one. You want the option. You want the option because that's the only way you get economy. You basically want to go and use the best infrastructure that is available to you when you need them, right? So this is the reality of today. And we want this infrastructure to become magical. We want this infrastructure to be ubiquitous, fungible, reliable, and secure without you having to figure out when my application is crossing my on-prem boundary and going to public cloud, or when my packets are crossing my network boundary and going over public internet, or when my users are connecting to my data center or a Microsoft or an Amazon or a Google data center. You shouldn't have to worry about that, because if you do, then you don't have a single seamless infrastructure, right? That's the problem that we're trying to solve. That is the multi-cloud problem. That is the multi-cloud problem to be solved. So how do we go about it? We go about it by attacking the layers that we need to solve. The first thing that you're solving is how do you connect? If you go back and look into the 4 principles that I talked about of public cloud or private cloud, really cloud as a technology, right? Ubiquity and reliability comes because of connectivity. You actually have infrastructures that are seamlessly connected. Now, what does connectivity mean? You have switches, you have routers, you have Juniper, you possibly have non-Juniper switches and routers. As much as we wish that all the packets flew in software, well, the reality is that at some point, some silicon is forwarding packet. You cannot wish complexity away. It's there. It's there because that's the most economical way for you to forward packet. As much as people would like you to believe that overlay is the solution to all problem. Well, I'm a big believer of overlay. We have one of the best overlay solutions in the industry, but you cannot forget the underlays. And you cannot forget the underlays that are from Juniper and from other vendors because most of you want flexibility and choice. You don't want to be locked into one thing. So we are solving the connectivity problem where you connect. You don't have to choose between whether it's overlay or underlay, whether it's from Juniper or from some other vendor, whether it's merchant silicon or custom silicon. The problem that you're ultimately solving should be a problem of what is the physics of the problem and what is the economics of the solution. Folks keep on asking me, do you do merchant silicon and do you do custom silicon? My answer to them is always, look at your laptop or your tablet. You can do video rendering in the CPU. It works great. It's slow and it's expensive. So you have a GPU. You use special purpose custom silicon for some things for which it's the most economical solution. It's not because it is cool. It's the most economical solution. So when you're connecting, there are some applications where it is performance heavy, and it is high speed, high throughput, where custom silicon does the best. So we have custom silicon. But then there are other solutions where you don't do something that complex in your silicon, or you need the flexibility of the software. So we support merchant silicon. And by the way, I count x86 and ARM processor as part of merchant silicon because it's not overlay and underlay. It's the best way for me to forward packets and apply policies. We have no religion here at Juniper. We will build the most economical solution for you, be it overlay or underlay, be it custom silicon or merchant silicon. But the way that we're going to do it is so it's simple. And the way that you get simplicity is one OS for every element, be it physical silicon or be it virtual. Junos, the same Junos that you have known and loved for the last 15 years, same Junos. When you buy a physical SRX as a firewall, or you take the same SRX software and run it as virtual SRX on an Amazon or a Google Cloud, same Junos. When you go and take a MX and you take the same use cases and apply them into a virtual MX, it's the same Junos. One OS, you don't have to retrain your operators because it's the same OS with the same tool sets that you have seen all this time in both physical and virtual. And we'll have one platform for you for managing all of these complexities. And as Rami said, that platform is Contrail. Physical, virtual, Juniper, non-Juniper, private cloud, public cloud. One platform called Contrail with one simple way of managing it. And that's the next important part is orchestration, right? So what is multi-cloud? I mean, there are many definitions of what multi-cloud is, right? So let me share with you my definition of multi-cloud and Juniper's definition of multi-cloud. It is the infrastructure where your applications and your users can seamlessly use whichever cloud infrastructure is the most economical and the best for the solution, be it on-prem and be it public cloud. And it is, of course, multiple public cloud, because none of you want lock-in into a single public cloud, right? So ultimately, the solution to solve for multi-cloud is how do I provide a single seamless connectivity, resource management, micro-segmentation, security implementation across the board, where when you're applying a security policy, you are not parsing in your head, am I applying that to a firewall for perimeter security, or is this application security that is applied on Contrail for Contrail security? You should not have to worry about it. We will take care of it, and we'll take care of it in software. To you, what you should worry about is what your users worry about. When I go and when I move these workloads, or when I have applications that move between multi-cloud, should I worry about the security posture? No, you shouldn't have to, because you should get the safety of Juniper policy and orchestration where it is the same security policy. It follows your application. It follows your users. You don't have to do it. We got it covered for you in software. So with that, you know, the real benefit that you end up getting is that now you actually have an infrastructure that is seamless because it's connected and it is orchestrated with the common policy, common microsegmentation, common security posture. So we believe that this is one of the most powerful things that we're doing with Contrail. And by the way, just to make it clear, it is for overlay and underlay, and it's for Juniper and non-Juniper gear that you may have from your past. Of course, it will work magically with Juniper gear. That is no surprise. So I'm here very proud today to announce this new product offering that we are offering for you, especially for the enterprise customer. It's called Contrail Enterprise Multicloud. The idea being that we're taking all the power that Contrail already had in being one of the most popular overlaid SDN infrastructure in the world and enhance it with support for underlays and support for public cloud across the board. We have the software, so you don't have to do it yourself. I'm really, really proud of the software that we're bringing to the market for the first time to really solving multi-cloud as a common software package. Next part, you know, I used to run, as I said, a very large infrastructure, you know, global infrastructure for a long time. And I often used to tell my team, you know, look, sometimes I feel like I'm flying blind. I'm sure many of you feel that. You come to work someday and something is broken, and you are shuffling through 25 dashboards that you have open, and you're trying to do a visual version of event correlation, because sometimes that's the best tool that you have. right? You're looking through, I'm sure this sounds familiar. This used to be my life. You're looking through 5 tabs in one browser and 25 tabs someplace else, and then you, of course, have the public cloud tabs, right? And your visual correlation is how many of those dashboards are blooming red because something is going wrong. Look, I say something oftentimes to my team. People talk about big data. Data is not meaningful. Information is. If you cannot take data and turn that into information, it is useless because you'll drown in sea of data, right? So ultimately, what is important is my data accessible to me in a form that is consumable to me and my operators, and can I do something meaningful with it? We're solving that for you with the platform called Aformix. And the idea here being single pane of glass for complete multi-cloud visibility, overlay, underlay, compute, storage, VNFs, PNFs, whatever you have, with the goal of giving you operational analytics to actually know what is breaking. This will take care of doing things like multi-factor correlation for you, so that when something is broken, you don't have to figure out whether that's my VM or my VNF or a physical network somewhere. It does that for you. It doesn't stop there. Once you have the data, why should a human have to act on it? Software should be smarter. Actions should be simpler. And yes, we're making it simpler for you. State-driven orchestration, where not only do we make sense of what is going on in your infrastructure, we come up with the action that you should take based on those data and information that we have gathered, right? Role-based monitoring and alert, and finally, data-driven capacity planning. Like, one of the hardest challenge of doing multi-cloud is how do you figure out how much of private cloud I still need to build out, how much of my resources are going to move to public cloud, how do I figure out how do I do capacity planning? It's a very hard problem. We're solving it for you. And look, I'm an engineer. I really wanted to do a demo for you because all this, again, beautiful PowerPoint slide, very nicely done by our marketing team, great job. It still doesn't prove that it works. So I really wanted to do a demo for you because I came to Juniper and I saw that Aformix demo and my eyes lit up. Like, this is what the industry wants. Well, if you go outside, we're actually going to have a demo of everything that I stated in the booth. This is not PowerPoint slide. It's software that actually works, and it works today, and you can buy it, and it's being deployed by some of our largest customers to do exactly this. So, okay, you have connect, you have orchestrated, you see the infrastructure that you have, now you have to secure it. And the challenge of security is that, again, we are seeing a complete disruption of the old paradigm of security. It's not about securing your perimeters because your perimeters are not defined anymore. If you have applications that used to be in your on-prem data center and you had a very strong security posture, and now you have moved it to public cloud, and you keep on hearing about not only containers but serverless, right, where your applications have moved across public cloud in various different ways. How do you take the security posture that we are so used to and your users are comfortable with, and you apply them to the new model? So what we're doing here is, you have heard of software-defined secure network. We're leveraging the strength that we have in our most performant firewalls, both physical and virtual, and the strength that we have in Contrail overlay with Contrail security, and adding visibility and machine learning-driven analytics to that with advanced threat protection, and giving you an infrastructure that is secure end-to-end. It's not a choice that you have to make. Common policy, common security posture, common microsegmentation, common ways of connecting applications and users across the infrastructure. It's secure. So all that sounds great, right? And where are we in making all of this real? Well, all of this is real. Here's an actual example of that. eBay Classified, right? So they actually had a very large legacy IT infrastructure that they had to keep on operating. But they're also trying to move very fast to offer a new set of services globally. And what they really wanted to is, they're looking for the simple button. I need overlay, I need underlay, I want all the greatness that SDN brings. I want my applications to be cloud native if I can make them, but I want them to do in a simplified way. So guess who they went to? They chose the most deployed OpenStack overlay Contrail, and they went with Juniper switches. And by the way, we're also supporting the legacy hardware that they have, and they turned all of this new infrastructure, including services, up in less than 6 months. So we're really proud to be part of this story, and what I'm really hoping is that throughout the day, I'm going to hear from you on either you have done some similar experiments or you're thinking of solving some problems. Please come up and let us know how we can solve, because we're solving the similar problems for all of our users. And that's the goal of all this software that we're building, right? Look, I actually do think that we are really part of something very exciting. I bet my career on this journey, and I really strongly believe in the hardest problem to be solved for networking and for infrastructure going forward. And Juniper is the company to bet on. I know many of you have bet your infrastructure on us, and I'm here to actually tell you that we have made the right bet. In the data center space, Juniper has had an amazing growth. It is the fastest new logo growth in this space. It is the largest cloud franchise. As I said, hyperscalers have the advantage of going and rethinking their infrastructure. Every time they did that, they went with Juniper. It's the largest cloud franchise that is envy of most of our competitors and peers in the marketplace. And it is by far the largest deployed multi-cloud controller when it comes to OpenStack. Like, we already have these building blocks that are running mission-critical applications and infrastructure around the world. We are adding engineering simplicity on top of that. That is what your multi-cloud future looks like. And we're here to make it real for you. And today and tomorrow, you're going to see how we're solving each piece of this problem. And then we have wonderful demos outside in the booth. If you want more details, stop by and see them in action. We are here to solve multi-cloud with engineering simplicity. And it's a really exciting journey. But wait, we're not done yet. Did I mention Juniper believes in open? Juniper believes in open. We always have. All the Juniper APIs have been open. All the Juniper configurations have been open. And Contrail has been open sourced since 2013. It has always been open. We're taking it one step further. We're taking the open Contrail code, and we're moving it to the Linux Foundation networking projects. And the idea being, it is not just about Juniper solving hard problems. We want the community to participate and guide us and drive us to solving this hard problem together. So being part of Linux Foundation and being community-driven, we are opening up this wonderful opportunity for us, but also for you, to come and drive and participate and lead and build the best multi-cloud future that we can all build together. So it's a really exciting journey. I'm really excited to be part of it, and I hope you're excited about where we're going with this story. Thank you very much for your time.